Inequalities. Hi, I'm teacher Malyn. Lesson 1 of chapter 4 is about system of linear equations in two variables plus systems of linear inequalities. I forgot to write. Okay? What is a system of linear equations? It is a system of linear equation is composed of two or more linear equations with the same variables. And each system of linear equations in two variables can be solved by substitution method, elimination method, comparison method, and graphical method. The possible graphs of systems of linear equations in two variables could be intersecting lines. So this is the y-axis, the x-axis, and these are the intersecting lines of the given system of linear equations. The point of intersection is the solution of the system of linear equation. If the graph looks like this one, an intersecting line, this means there is only one solution in the system of linear equations. But if the graph of the system of linear equations are parallel lines, this means that there is no solution to this given system of linear equations. But if the graph looks like this, wherein the lines coincided, so this means, okay, there are many solutions to the system of linear equations. So these are the three possible graphs, okay, of any system of linear equations in two variables. Determining the number of solutions of a system of linear equations without actual graphing. How will you do that? How can you determine, how will you know the number of solutions a system of linear equations will have without actual graphing? Okay? Let us be guided with the standard form of equation of a linear equation wherein it should be ax plus by equals c. So this is, I want you to note the numerical coefficients of x, the first term, numerical coefficient of the second term, and the constant. Then we are going to get the ratio of the first equation in relation to the second equation. Okay, look at this one. This is the ratio of the first terms, the ratio of the second term, the ratio of the third term, and so on and so forth. So, a linear equation has one solution if the ratio of the first term of the system of first terms of the linear equation is not equal to the ratio of the terms of the second term. Example, 4m and 3m, 2p and 4m. Look at the numerical coefficient. The numerical coefficients, we have 4 is to m, is to 3, is not equal to 2 over 4. So, if the case is like this, that means we're expecting that the system of linear equation has only one solution. Do you get me from here? Okay, what about a system has no solution? If the second term and the constant are not equal. Or should I say that, yes, and the first terms, the ratio of the first term and the second term are equal. But let's focus to the second term and the constant. If the case is like this, that means the system has no solution. But we have also to consider that the ratio of the first term and the second term are equal. Okay, look at the example here. We have a plus b equals 9. The other equation is a plus b equals negative 4. Okay? As I was saying, okay, see to it, the ratio of the second term and the constant are not equal. If the case is like this, we expect that the system has no solution. Because in this situation, the second term and since the first term and the second term are equal, so it could happen that the first term and the third term are not equal because the first term, the ratio of the first terms and the ratio of the second term are equal. So if the ratio of the second term and the third term are not equal, therefore we can say that the ratio of the first term and the third term or the constant are also not equal. So let's go to the example again. You will notice that the ratio of the second term, this is 1, 1. So 1 to 1. 1 is to 1. Okay, 1 is to 1, and the ratio of this is 9 is to 4. Therefore, they are not equal. The ratio of the first term, 1 is to 1, is also 9 is to 4. So therefore, the ratio of the first term is not equal to the ratio of the constant or the third term. So this means that we are expecting if the ratio of the second term and the constant are not equal, no solution is expected. What about if the ratio of the first terms, the ratio of the second terms, and the ratio of the third term are equal? So this simply means that there are many solutions expected in the system of linear equations. Look at the example. What is the ratio of 8 is to 4, lowest term? 2. What is the ratio of 2 over 1? 2. So we can have it in ratio form. The ratio of 8 is to 4 is 2 is to 1. The ratio of this is the A, and this is the B, and this is the C. The ratio of the second terms is 2 is to 1. And the ratio of the third term is 2 is to 1. So all of them are equal, all the ratios. If that is the case, we have to expect that the given system of linear equations has many solutions. Do you get me po? Do you get me? Very good. You paid attention very well. That's why you got me. Okay, very good. Did you copy completely? Any question with the examples? Especially the one determining the number of solutions of its system of linear equations? Okay, if there's none, So this time, you can try this. So you copy an answer, then you follow the the pattern, and the example on determining the number of solutions of a given system of linear equations. Okay? Do it now.
Tahong